Okay. Hello everyone. In today's session, I will give you the concept of circular races. So there are questions on circular races that you encounter in most of these competitive examinations. So let me give you a concept, and then we'll move on to solving these questions. So in a circular race, probably there can be 2 guys, 3 guys. They can either move in the same direction or they can move in the reverse direction. Anything of this kind. But the kind of question that you will encounter will be, let's say if there are 2 guys, they are moving in the same direction. Right? So when is it that when they will be meeting for the first time anywhere on the track? They can meet anywhere on the track for the first time. Or when is it when they will be meeting for the first time on the starting point? And at how many distinct points are they going to meet in case it's a race which is of infinite rounds? So let's say my question is that it is given that the length of the track is 500 meters. That means this entire track is of 500 meters. There are 2 guys, A and B. Speed of A is 2 meters per second and that of B is 5 meters per second. And they are moving in the same direction first of all. Question number 1 is, find the time after which they will be together for the first time at the starting point. For the first time at the starting point. Second is, when will they meet for the first time anywhere on the track. And the third question, as I told you, was at how many distinct points will they meet on this track in case it's a race which is of infinite rounds. Right? So these 2 questions seem similar, but there's a different approach for solving and their answers are also different. So you need to be very clear about solving these kind of questions. So let me go by very basics. Let's say if I want to find when will they meet for the first time at the starting points, let's start that. Let's try to find out the time taken by A to cover 1 full round. That will be nothing but the length of the track divided by its speed, which is 2. So 1 by 2 comes out to be equal to 250 seconds. That means after every 250 seconds, A is going to be at the starting point. That means first time it is going to be there at the starting point after 250 seconds. Second time A is going to be there at the starting point after a multiple of 250, which is nothing but 500, then 750, then 1000 and so on and so forth. While if I want to find the time taken by B to cover 1 full round, it is going to be nothing but the length of the track divided by speed of B, which is 5, which will come out to be equal to 100 seconds. That means B will be always there at the starting point after every 100 seconds or a multiple of 100 seconds. That means 100, 200, 300, 400 and so on and so forth. So here it comes into application, the application of least common multiple. So as A is always going to be there at the starting point at 250 seconds, a multiple of 250, so second time it is going to be there at 500 seconds, then at 750 seconds, then at 1000 and so on and so forth, while B will be there at 100, 200 seconds after every 300 seconds, then 400 seconds, then 500 seconds and so on and so forth. So first time when both A and B they are going to be there will be nothing but least common multiple of 250 and 100, which will come out to be equal to 500 seconds. Which is a multiple of time taken by A to cover 1 full round and time taken by B to cover full round. So they will be there at the starting point for the first time after every 500 seconds. I hope you have understood this. Now, let's say I want to move on to my next question, that when is it for the first time that they will be there together anywhere on the track. Now, as both of them they are moving in the same direction, we know that when 2 guys move in the same direction, their relative speed is subtraction of the 2. So the time when A and B they will be together for the first time anywhere on the track will be 500 divided by their relative speed, which is 5 minus 2, that is 3, which will come out to be equal to 166.66 seconds. So 166.66 seconds is the time when they will be together for the first time anywhere on the track. Now you also need to understand it this way, that they'll be together for the first time anywhere on the track when the faster one would have taken 1 extra round as compared to the slower one, because the faster one will be catching the slower one from the back, and that is only possible when the faster one would have taken 1 extra round as compared to the slower one. So you can look at this. This is again very simple. What I am telling you is that after 166.66 seconds, both A and B they are together anywhere on the track. So you can find the distance traveled by A in 166.66 seconds. Distance is speed into time. Speed of A is 2 meters per second into 166.66 seconds. So this will come out to be equal to 333.33 meters. While distance travelled by a bee in the same time will be 5 meters per second, which is the speed of the bee, and time when they are together anywhere on the track is this much. So this will come out to be equal to 833.33 meters. So if I want to make this or show this to you on this track, this entire track is of 500 meters. So this is 500. If I divide into 3 parts, so this is going to be 166.66 meters, and this is going to be 333.33 meters. So when they are meeting for the first time, A has travelled a distance of 333.33 meters. So if this is 0 or 500, if it completes the entire thing, this is going to be 333.33. So A is here for the first time after 166.66 seconds. While B has travelled a distance of 833.33, you can write this as 500 plus 333.33. This will make things more clear. That means B has covered one full round and an extra of 333.33. That means it has travelled one extra round as compared to A and has caught him from the back. So this is what it is. And the time that we have calculated is 166.66 seconds when they meet for the first time anywhere on the track. They meet for the second time anywhere on the track, which will be at a time which is a multiple of 166.66 seconds, which is nothing but 333.33 seconds. This is for the second time when they've been meeting. They meet for the third time at a time which is again next multiple of 166.66, which is nothing but 500 seconds. And which apparently is also the time when both A and B, they are together at the starting point. Fine. So that means they have met at point after 166.66 seconds, then after 333.33, then after 500 seconds. And after 500 seconds, we know that they are there at the starting point. So at the starting point, once they are there, then next time they are meeting, they are going to meet here, and then here, and so on and so forth. That means you can directly conclude that in this entire race, which is of 500 meters, they will be meeting at 3 distinct points after 166.66 seconds, after 333.33 seconds, and after 500 seconds. Or you can also say that when these two guys, they move in the same direction, the number of distinct points in which they meet is going to be the subtraction of the most reducible form of their races, of their speeds, which in this case is 5 minus 2, that is nothing but equal to 3. So that is how you need to solve these kind of questions. In case I convert this, you can also do it, in case I convert the directions, then again the concept remains the same and you can solve these kind of questions again.